Let's talk about the benefits to using fiber, both in general and also in an application where it's going to be AV specific. So we'll talk more about the types of fiber in a second, and by that I mean the differences between what they call multi-mode and single mode. But just to give you an example, the first few things that come to mind when talking about fiber is the ability to transmit lots of data super quick over a long distance. Okay, so to give you an example of that, multi-mode fiber, once again, I'll explain that in a second. Multi-mode fiber can transmit 100 gigabit per second up to approximately 500 feet or 150 meters, right? So that's 100 times 10 to the power 9. So imagine 100 with 9 zeros behind it. That's the amount of bits per second that multi-mode fiber can transmit, okay? On the other hand, single mode fiber, again, explanation of that will be provided in a second. Single mode fiber can theoretically transmit 1.2 petabits of data over, again, in theory, an infinite distance. All right, now 1.2 petabits is 1.2 times 10 to the power 15. 1.2 with 15 zeros after it. That's how many bits per second theoretically a single mode fiber optic cable can throughput data, all right, at almost the speed of light. It's not quite the speed of light because we're not going through a vacuum, we're going through a glass medium, to a distance which, in the case of single mode is theoretically infinite, but it's not quite. With multi-mode, we start talking about distances up to about 11, 12, 1300 feet. So a great deal more distance than you can copper infrastructure. We also talk about latency as well. Latency is becoming more and more important nowadays, as in our industry, we're seeing the convergence of AV and IP. So a lot of information now is transferred by way of the IP infrastructure, the network switches and such. And in order for that to happen successfully, we need data to get from one point to the next as instantaneously as possible. Otherwise, data packets get dropped, they arrive at the wrong time, and the system fails. Okay, so latency of those data packets needs to be as close to zero as possible. Some of the peripheral benefits that we speak about with fiber that quite often go unnoticed or unrecognized are, the fact of the matter is, unlike copper and other types of medium, fiber has no metallic or electrically conductive components to it, all right? So that means that it is immune to things like power surges, EMI, electromagnetic interference, radio frequency interference, ground loop interference, and even lightning as well. So because it's non-conductive, it has no metallic parts, it's immune to a lot of those things. And not only that, but it doesn't corrode, all right? Because there's nothing metallic in there, can't corrode. So if you're in an environment which is very high humidity environment, maybe by the coast where there's a high salt content, or if you're a marine application, you're doing stuff on some of these super yachts, the fact that you're using fiber makes you much more resistant corrosion because there's nothing in there to corrode, all right? Fiber is just as easy now, if not easier to terminate than copper, and certainly, our fiber is easier to terminate than other fiber out there, and we'll prove that to you today. And it's becoming more affordable. So to give an example of that, the typical cost of what we call a duplex fiber. A duplex fiber is two strands which would normally be used to interlink two network switches together. A typical cost of 1,000 foot of duplex is now fairly comparable to a cost of 1,000 foot of Cat6 or Cat6A. All right, so the fiber itself is not only becoming far more comparable in price to the cost of copper, but also the endpoints are as well. All right, so the endpoints traditionally for fiber have been, far more expensive than the copper infrastructure endpoints you would use for twisted pair. That disparity in price is now being vastly reduced, and that disparity is now almost zero. So to the point where, in actual fact, when you consider how easy it is to terminate the fiber now, how strong the fiber is, and the capability of the fiber, one might almost argue that the overall cost of a fiber infrastructure is very, very comparable to a copper infrastructure now when you take into account labor and everything else. Okay, so it's become much more affordable, and it can handle future technologies. In its raw sense, fiber has been fundamentally the same for 60 years. All right, so and it's never outgrown technology, and nor do we see it outgrowing, being outgrown by technology going forward. We're dealing with data information that's being passed at almost the speed of light, and theoretically to an infinite amount. So future technologies are not a challenge for us in the fiber category. Okay, it's lightweight as well. It must not be forgotten that handling cable is quite cumbersome sometimes, and pretty tough. Fiber is lightweight, so again, as point of comparison, a shielded Cat6a, a spool of shielded Cat6a, 1,000 feet or 300 meters or so, that's generally running at about 50 pounds or 23 kilos for that spool. So that's pretty difficult to be lugging that around and pulling it through infrastructure. Comparably speaking, a 6-strand fiber optic cable of 1,000 feet, depending on the jacket size, is around about 14 pounds. Okay, so 14 pounds versus 50 pounds is significantly different. It becomes much easier to handle, takes up less room, and generally speaking, it's much more pleasurable to use than twisted pair.